Now we understand the concept of abstraction. So in Java, abstraction is achieved by using abstract classes, but it can also be achieved by using something called an interface. How do we define an interface? Well, think of abstract classes first. In an abstract class, we start the declaration with an access modifier, the abstract keyword, and then we say that this is going to be a class, and then we name the class. Let's say vehicle. So this is how we start an abstract class. For an interface, what we do is we have the access modifier at first, but then we use the keyword interface, and then we use the name of the interface. The most basic form of an interface can have two things. It can have attributes and it can have method signatures. The attributes by default are public, static, and final. Because they are public, static, and final by default, we do not have to use those keywords when we are declaring the attributes. The methods of an interface are public and abstract by default. Again, these are just method signatures. We do not implement the methods here. They are abstract by default. How do we use an interface? It works almost the same way as using abstract classes. However, abstract classes are inherited from, which means that when another class wants to use an abstract class, that class uses the keyword extends. But when a class wants to use an interface, it uses the keyword implements. So if we have another class that wants to use the interface that we have defined here, it would use the keyword implements followed by the name of the interface. Now, when this class implements this interface, this class gets access to all the attributes, which are public, static, and final. Each attribute is a public, static, final attribute. So attribute 1 is public, static, and final. Attribute 2 is public, static, and final, and so on. And this class will have access to those attributes. For methods, we will have the same mechanism as that of abstract classes. These methods are abstract methods. And if this class implements this interface, this class must implement these methods and provide the implementation code. So the car class will have its own attributes, it will have its own constructor, and it can have its own methods, but it also must override all the methods that came from the vehicle interface, and it must provide the implementation code for all those overridden methods because it implements the vehicle interface. And just like we saw with the abstract classes, if a subclass does not implement one of the abstract methods or any number of the abstract methods, then that means that it is still incomplete. One or more of the methods have not been fully defined in the class that implements the interface. And if that happens, then this class must be declared as abstract, just like we saw in the case of inheriting from an abstract class. But here we are inheriting from an interface and it behaves the same way. If we do not provide the implementation code for any one of the abstract methods, for example here we only provided the implementation code for 2 of the abstract methods and left one out, that means that this is still incomplete. That is why this has to be defined as abstract. But if we go back to how we had it previously and do provide all the implementation details of all the abstract methods in the interface, then this can become a concrete class. A big difference between interfaces and abstract classes is that abstract classes can have methods that have some implementation. Abstract classes can have their own methods with implementation. However, an interface can only have abstract method signatures. There can be no implementation code in an interface, which is why sometimes it is said that interfaces provide us with total abstraction. One other thing to keep in mind is that a class can implement multiple interfaces at the same time. So let's say we have another interface named engine, and let's say that this this is how our interface looks, then if the car class requires it, it can implement the engine interface as well. All it needs to do is separate them with a comma and say engine here as well. And that way the car class will be implementing the engine interface as well. And you can implement as many interfaces as you require for your class. And that is an advantage because you can only inherit from one abstract class. Inheritance only works with one parent, but with interfaces, you can implement as many interfaces as you require. Also, if an abstract class has any attributes, those attributes are not anything by default. But for an interface, all the attributes are by default public, static, and final. So you can think of interfaces as complete blueprints of classes. Abstract classes were partial blueprints because abstract classes had some attributes and methods, and some of those methods might have had their own implementation code in the abstract class, right? But when you inherited from an abstract class, you would only have to implement the code for the abstract methods. However, if a class is implementing an interface, then that class needs to provide the implementation code for all the abstract methods of the interface. If a class implements an interface but does not provide the implementation code for one, two, or all of the abstract methods, even if any one of them is missing, let's say as we showed before, let's say this one's missing here, then we have to declare this as abstract, and some other class that inherits from this class must override the remaining abstract method and provide the implementation code. Which means that in this chain, we have the interface, the car, and the Toyota class. These three methods have to be implemented, and it doesn't matter who implements which one of these in this chain. And of course, since car implements the engine interface as well, this also becomes something that needs to be implemented. Again, either this class or this class needs to implement this method here as well. So let's say car does it and provides the implementation code. A couple more things. An interface cannot be instantiated. So you cannot create objects from an interface. And secondly, an interface can extend other interfaces, meaning that you can have something like this. And this would mean that whatever abstract methods and whatever attributes this interface has, vehicle will inherit all of them. So if car implements vehicle, then car must provide the implementation code for these methods, as well as all the methods that are abstract in this interface as well. Of course, this would extend car. And to complete this example, let's get rid of this for now. And if we look at this interface and this interface, we'll see that car implements both of them. That means we have 1, 2, 3, and 4 abstract methods that must get their implementation code somewhere. And so method 1 got implemented here. Method 2 got implemented here. Method 3 got implemented here. And method 1 from engine got implemented here. Since the car class implements vehicle and engine, but does not provide the implementation details for all 4 of these abstract methods, it provides the implementation details for only 3 of them. That means car is still incomplete and needs to be declared as abstract. So we cannot create objects from car since it's abstract. We cannot create objects from the vehicle interface or the engine interface. But since the Toyota class completes the last abstract method remaining as well, Toyota becomes a concrete class. And so from Toyota, we can create objects. So I hope you are clear about the mechanisms of how interfaces work.